Good morning. So today we're going to work on 6.4, solving compound inequalities. Remember, inequalities are, instead of an equal sign, you're working with the less than, the greater than, the less than or equal to, or the greater than or equal to. That's when an inequality is, because it's not equal. Exactly. So I want you to, whenever you're doing these recordings, I'm going to ask you to kind of pause and try the warm-up, and then come back and check your answers, just like we do in class. You know, I can't make you do it, but it's always a good idea, just to make sure you remember how to do things from before. So right now, right now, why don't you do that? Pause for a moment, try these 1, 2, and 3, and then come back and check and see how you did. All right, here we go. So hopefully this is what you got. When you solve this inequality, hopefully you realize that this 1 wasn't part of that inequality. It's just the number 1, first problem. But you subtract 10 from both sides, and you get this. X is less than negative 2. If you flip it around, it would be like this. Either way is acceptable. They mean the same thing. Same with this one. You add 4 to both sides, and you get this. And then you divide by 2, and you get X. I just wrote it in words here. X is greater than or equal to 5. Okay. Here you estimate you can read at least 8 history text pages per day. What are the possible number of days it will take you to read at most 118 pages? So your unknown is days. What are the possible number of days? So I made D equal to days. And I know that I can read at least 8 pages per day. Could be more, but I can read at least 8 pages today, and I don't need to read, a day, and I don't need to read more than 118. So 8 times D, less than or equal to 18. That's the most I have to read. And then I just solve it, and it says D is less than or equal to 14 3/4 of a day. That means I could take up to 14 days if I only read 8 per day. I could read more than that, and it would take me less than 14 days. So that's why I wrote my answer as up to 14 days. All right. Okay, let's take some notes on compound inequalities. And what they are, it simply means that they involve more than one inequality. It's going to have an and or an or in these compound inequalities. And you'll see what I mean here in just a sec. All right, the graph of a compound inequality with and is the intersection of the graphs of the inequalities. It's called a conjunction. You don't need to worry too much about this word. Just kind of in there. I mean, you probably won't see it again, but just so you know, that's what it's called. When it's an and, if you were to draw it as a Venn diagram, that means there's going to be this intersection here. That's an and. All right. The graph of a compound inequality with or is the union of the graphs of the inequalities, but it's disjunction. Again, you don't really need to know this word. It's in the book, but probably won't see it again. But they don't overlap at all. So it's going to be these numbers and these numbers. Or. Okay. Translate the verbal phrase into an inequality. Actually, let me add a little bit more here. On a number line, if you were to graph an and inequality, it's going to be everything like this. In between those two, that's an and. If you were to graph an or on a number line, it'd be like this. They face away from each other. I like to say kind of like this or away from each other. And graph or graph. Okay? Translate the verbal phrase into an inequality, then graph the inequality. All right, so we got to put it into an inequality, and then we have to graph it. 2 things. All real numbers that are less than negative 1. What I want you to do is I want you to write both the inequalities, and let's just see what it turns out, and then we'll graph it, and we'll see what happens. X is less than negative 1, or greater than, the or should be here, don't circle that one, or greater than or equal to 4. So this is an or. Okay, if you were to graph it, you would see that. So I'm going to graph this one first. I'm going to put it on -1, and then I'm going to put 4 down because those are the two numbers I'm working with. I'm going to graph this one first. It says all my x's are less than -1. Remember, when it's less than, it's an open circle, and it's everything less than. This number line is representing x. This one here is greater than or equal to 4. When it's greater than or equal to, I got to put a solid dot on 4 and everything this way. You can see that these are pointing apart from each other, so it is an OR graph, so you're just going to write it as two separate inequalities up here. X is less than -1, or x is greater than or equal to 4. Okay? Now here's another one. All real numbers that are greater than or equal to -3, so there's one of them, and, oh, there's an and right there, less than 5. Okay? So let's just write what we know. We know x is greater than or equal to -3, and we know that x is less than 5. If I were to graph this, I'm going to have -3 and 5, solid dot here, open circle here. Now this one here, it says x is greater than -3, so it's going to go in this direction. However, x also has to be less than 5, so it's just going to be this piece in between here. See the difference between the two. This is an OR, this is an AND. And when you have an AND graph, you just place the x in the middle, and we're going to put these two inequalities together. I'm going to write this one first. I'm going to put -3 here and 5 here, because that's a smaller number, just like in my graph. And x is greater than or equal to -3, but it's also less than 5. So you kind of write it like this. And inequality, or. And or. Okay? Let's practice some more. At an auction, the lowest bid for an autograph trading card is $20. So that's the least that somebody will pay for it is 20 bucks. The highest bid is 54. That's how high somebody is willing to pay for that card. Write and graph a compound inequality that describes the possible bids. This tells me that it could be between 20 and 54. So it's going to be greater than or equal to 20, but also less than or equal to 54. So that's going to be an AND if you think about it. Okay? Let's graph it first and just make sure. So I'm going to put 20, I'm going to put 54, and now I'm right here. It says x is going to be greater than or equal to 20, so it's a solid dot, and it's this way, but it also won't go higher than 54, so it's going to be a solid dot and this way. So this is an AND graph. Okay? So that means I'm going to put my x in the middle. I have 20 here and 54 here. If I think about this one first, it's greater. X is greater than or equal to 20, but it's also less than or equal to 54. And these are your x values here. Okay? So that's an AND. All right, turn it over. I don't really like this. I'm just going to have you do one way. Okay? It's two ways, but I think that's kind of confusing. So we're just going to solve. We're going to find the x values that will make these inequalities true. Since it's an inequality, there's going to be a whole bunch of them, not just one x. Okay? We'll represent that with an inequality. So let's just cross this one off because we're just going to do it one way. So right here, you see that x minus 5 is between -7 and 4. This says that x minus 5 is greater than -7, and x minus 5 is less than 4. So we're going to solve for x by getting it by itself. It's x minus 5 here, so I'm going to add 5. But I also have to do it now to both sides on the outside of each of those inequalities, however you want to look at it. So that goes away. And I have -7 plus 5. I have -2 here. I still have that inequality. Doesn't switch directions. I didn't divide by a negative number. I still have x. Then I have that inequality, and I have 9. This tells me that x could be greater than -2 and has to be less than 9 to make this inequality true. So I could plug anything in between -2 and 9. So I'm going to graph this. -2, 9. This part right here is an open circle. It's greater than. This part right here, open circle, less than. It's an and graph. These here are all the values of x that will make that inequality true. Let's do another one. Same thing. We have this in between these two numbers, so we got to get y by itself, just like solving an equation. First we subtract 4 from all three places. This goes away. 6 is less than or equal to 2y, which is less than or equal to 20. And then, now y is not quite by itself, yes, so I have to divide by 2. Everything, though, I got to divide everything by 2. Oops, not a negative, sorry, not a negative. Now, it's a positive 2, so I don't flip the inequalities at all. 6 divided by 2 is 3, less than or equal to y, less than or equal to 10. Okay? Make a note to yourself. If you were dividing by a negative, you would have to flip the inequalities. In this instance, we were not dividing by a negative, so let's graph the solution set. So I have 3, I have 10. I'm going to graph this one first. Solid dot on 3. Y is greater than or equal to 3 this way. And it has to be less than or equal to 10. So solid dot on 10 and connect them. These are the y values that would work to make that inequality true. Okay, or, when you have an or, it's really easy. You just solve each inequality separately. And remember, the graphs are going to be out when it's an or. When it's an and, the graphs come together. Okay? So let's just solve this one. Plus 2, plus 2. 3x is less than or equal to negative 9. Divide by 3, divide by 3. X is less than or equal to negative 3. There's one of my inequalities. Now I got to find the other one. Minus 18, minus 18. 2x is greater than negative 2. Divide by 2, divide by 2. Also in this one, I am not dividing anything by a negative, so I don't flip any inequalities. Okay, so here are my two solutions. I got to graph them. So I have negative 3 and I have negative 1. Let's graph this one first. It says x is less than or equal to negative 3. So I put a solid dot and my arrow goes this way. This one says x is greater than negative 1. Open circle, my arrow goes this way. This is an or graph, and that represents all the x values that will meet these requirements. All right, let's do some more. Last problem here. Mars has a maximum temperature of 27 degrees at the equator and a minimum temperature of negative 133 Celsius at the winter pole. So a maximum of 27 and a minimum of negative 133. So that means Mars' temperature could be less than or equal to 27, but it's always going to be greater than or equal to negative 133 from what they've recorded so far. Write a compound inequality that describes the possible temperatures in degrees Fahrenheit on Mars. Oh my, look at the difference here. Here they're saying we've got to do it in Fahrenheit, but they gave it to us in Celsius. So that means you have to look up, or maybe they would give it to you, how to convert. Celsius degrees is equal to 5/9 F, that's Fahrenheit degrees, minus 32. Okay, so here's how I'm going to represent this. I need to find out what it's going to be in Fahrenheit if my Celsius temperatures are less than or equal to 27. So 5/9 F minus 32 is less than or equal to 27, but it's also greater than or equal to negative 133. This represents Celsius temperature. It's like my C in Fahrenheit. Think about that for a minute. So all I did was, instead of writing C here for Celsius temperatures, I substituted it in with the conversion equation that I need to get Fahrenheit. Okay, I mean, you could write it initially like this. And then you take this and substitute it in for C, which is what I did right here. All right, so then we have to solve for F here. So the first thing we have to get rid of is this 5/9. And to get rid of a fraction, remember, you multiply both the top and the bottom of everything by 9/5. Oof, this is a yucky problem. But not really. We can do it. Okay, so when I multiply these two together right here, negative 133 times 9 divided by 5, I get this, negative 239.4 is less than or equal to, this one away, F minus 32 is less than or equal to 27 times 9 divided by 5, which equals 48.6. So now I'm closer to just getting F, the Fahrenheit temperature. All I have to do now is add 32 to both sides. And this equals negative 207.4. This goes away, and I have my Fahrenheit temperature. And then add those two together, I have 80.6. So what this tells me is on Mars, the Fahrenheit temperature is greater than or equal to negative 207.4, but less than or equal to 80.6. Started with Celsius, we converted it to Fahrenheit. Graph your solution, then identify 3 possible temperatures in Fahrenheit on Mars. So I'm going to graph these two numbers right here. Negative 207.4, 80.6, this is Mars in Fahrenheit degrees. Okay, this one right here, I'm graphing that. It's greater than or equal to negative 207.4, so I put a solid dot, and it's this way, but it's also less than or equal to 80.6, solid dot this way, and there we go. All these temperatures in between here could be a temperature you could find on Mars. So let's just pick 3. I'm going to say, I don't know, pick 3. I'm going to say negative 200 degrees Fahrenheit, negative 1 degree Fahrenheit, maybe 75 degrees Fahrenheit. There's 3. Doesn't matter. Anything that would be in between here. Okay? All right. I did not print a calendar yet, so you need to look on the website. However, we will be doing these practice problems in class on Tuesday, so there's really no homework. We will work on in class Tuesday.